Hello students, in last video we have discussed about the bidirectional converter. Today we are going to see the sinusoidal pulse width modulation. Okay, for this one we'll try to observe it. Okay, so we'll take a mux block. How the pulses are going to generate, that we will try to observe today. I will take one. In order to copy paste this one, you can just right click on this scope and you can drag it. Okay, so I want three inputs. Okay, three, apply. Okay, fine. So in these three inputs, in one I would like to check my sign with the carrier wave. Okay, then I want to check the positive signals and the negative signal. Okay, so I will try to reduce the frequency so that we can able to observe the pulses properly. Okay, apply. Okay, fine. So now just run the program. Fine. So here we can able to observe. Here we can observe. We'll try to take one complete cycle. Okay, we'll try to take one complete cycle and we'll try to observe it. Okay, now our condition is whenever sine signal is greater than the carrier signal, then we are going to get a pulse. So you can observe the pulse here. Okay, similarly here again we can able to observe one pulse. Again here it goes on. Now whenever this pulse is on, this pulse, that is our complementary switches, that is negative switches, it should be turned off. Okay, when S1 and S2 is turned off, S3 and S4 has to turn on, right? This is the logic which we have written, right? So this is how actually pulses are going to generate. Okay, this is sinusoidal pulse width modulation. Fine. Now we'll try to we'll try to now we'll try to develop the unidirectional converter. Okay, we will try to develop the unidirectional converter. So in last class we have discussed about the unidirectional converter, right? That is, so this is our unipolar. Okay, unipolar we try to develop now. Okay, this is a unipolar where you are going to get one signal and it's another negative signal, that is opposite signal we are going to generate, and through this one we are going to develop a unipolar. Okay, for this one, now this is my sine signal. We will try to do some changes in this itself. Okay, so select these things, just press shift, then we can able to move it. Okay, press shift and drag it, that's it. Okay, I'm just trying to do some changes, that's it. Okay, so here this is my sine, the sine signal. Okay, this is my sine signal and I would like to generate another signal. Just take a gain. Okay, make it -1, that's it. Okay, fine. Now we have got two signals. One is normal sine signal, and then its complementary signal, another one. Okay. So now we are going to use the same repeating sequence and we will try to generate. Okay. This is my sine signal. And this is my repeating sequence. Okay. Remaining things are same as usual. Okay. So here I will try to take three signals now. Okay. Apply. Okay. So which are all the three signals? One is the sine signal, then another one is its complementary, and then my switching sequence. Okay. Then I will try to check my pulses. We will try to run it. So here we are going to get the unipolar, right? Unipolar sequence. Okay, if I increase the frequency, then you can observe the response. Okay, this is our response. Now we'll try to observe the pulse width modulation. Okay, I'm changing the frequency from 5 kHz to 500 so that it will be visible. Otherwise, it will be very small. Okay, it is very difficult to further visible. Okay, now you can observe here. Okay. You can observe here. So this is one sine signal, and then it's complementary another negative signal. Okay, like this. Now condition is when this is greater than that is modulating signal is greater than the repeating sequence, then we are going to generate a pulse. Okay. After this one, here also the same condition applies for this one also. So here it is going to be turned on. So in generally what will happen here, both the switches are going to turn on. Okay. So then how it will be, what output we are going to get, we'll see it. Okay. For this one I will try to take four signals. Okay. Four signals apply. Okay. And we'll try to 6. Okay. Now this I will be giving it to the voltage. Fine. Now we'll see. Okay. So when both are conducting, okay, when both are conducting, you can observe there is zero. Okay, when both are conducting, voltage output voltage is zero. Clear? When it is not conducting, where any one switch is conducting, then you are going to get the output voltage. If both are conducting, then you will not see any. So here you can observe, here also you can observe, here also you can observe. Okay, because all the switches when are they are going to connect it, then it will be short circuited. In short circuit, your output voltage is zero. Okay, so this is about the unipolar. Okay. Now we will try to find out the THD. Okay, so for this one already we have taken this logging data as V out. Okay, V out we have taken, and we will try to change this tag value V out 1. Okay, V out 1. Apply. Okay. Okay. Again we have to run it. Again we have to run it. Okay. Fine. Now I'll try to check the tools and then FFT analysis. Now this is my V out. See, earlier we have now two datas, V out and V out 1. V out is a earlier one. Okay. So we'll take the V out 1, and then timing I have taken 0.1 5 cycles. Since our switching fundamental frequency we have maintained 50. Okay, so here we have to maintain the 50. Here we have to mention the 50. Then up to 100 harmonics I want to check. Okay, display. That's it. Okay, so this is our THV, that is 53.09, and this is our maximum voltage. Okay, that is V max. Okay, and at the same time here I have maintained the modulating signal as 0.99. In case if I'm going to change this 0.5, okay, apply, okay, here you can see here 394. Now I have changed the modulating signal. Now we will try to see. Okay, so you can observe here the magnitude is reduced. It means that almost half of it, right? So it means that if you are going to change the modulating signal amplitude, then your output voltage is going to change. This is how we are going to get the variable output voltage. Okay, variable output voltage. Fine. Okay, so till now we have discussed all these things. Now let us see. In yesterday we have discussed about this local and global, right? So if I am going to create, this is a global switch. You can see here, this is global one, and here you can see it is a local one. It means that you can find out by observing here it is kept in a bracket. It means it's a local. If I'm going to create a subsystem, how to create a subsystem means first select whichever you want to make it a subsystem, then just right click on it and create subsystem of the selection. That's it. This is created. Okay. This is created now. Now you can see here its color is changed. Now I try to run it. I will try to run it. Let's see what is going to happen. Okay, this is the output. You can check here. Negative sequence itself is missing completely. Sir, why, sir? Because these two signals, they are not getting the pulses. Okay, these two are not getting pulses because we have mentioned them as local means this will be applicable only to this one. This is applicable to only this section, this subsection. So now I want to use this tags to outside also. Then make this as global. Okay, make this as global. Now your icon is also going to change here. You can see here. Okay. So now you try to run it. Now you will get it. Okay. So this is how global and local. So today we have what we have discussed. One is sinusoidal pulse width modulation for both bidirectional and unidirectional. I mean bipolar and unipolar. And then we try to find out the THD, and we try to find out the how the output we are going to get the variable output voltage. Okay, and we try to find out what is a how we are going to use tags as global and variable. Okay, global and local and global. Okay, the difference we try to find out. Fine. Okay, now I'm saving this file. So this is about the this video's lecture, and next lecture we are going to start the experimentation. Okay, so if you want three phase, then I will okay, in next video we will try to do the three phase. Okay.